And welcome to our next lesson, 10.3, page 424 for the 8th graders, and lesson 16.3, 724 for the 7th graders, where we're going to continue with exponents and scientific notation. We are going to apply what we learned to use the quotient of powers property to simplify expressions. And of course, I know that you know that the word quotient is very important because it tells us we are going to divide. Ladies and gentlemen, our essential question: how can you divide two powers with the same base? Now, ladies and gentlemen, you were asked to, and I know being a person of character and intelligence, you followed these directions. You went to the appropriate page, you took down some notes because you understand principles of intelligence say that if we do a little bit of self-teaching, we can gain more understanding so that then when we talk together and go through this, you can even understand more. Your conceptual knowledge increases dramatically by having an idea. So you went to the appropriate page, you took down some notes on the quotient of powers property, and you learned that when you divide powers with the same base, what do? Say it. That's right. I could hear all of you saying it. We subtract the exponents. When we divide powers with the same base, we subtract their exponents. Now, our previous lesson said that when we multiplied these powers with the same base, we added the exponents. Now we're dividing, so we're going to subtract the exponents. A quick example of what that might look like, ladies and gentlemen, looks like this. Let's do it numerically. So if I have, say, 9 to the 5th divided by 9 to the 3rd, what they're saying is that I'm going to subtract those exponents because I'm dividing. So I'm going to write 9 to the 5 minus 3, which 5 minus 3, that would be 2. Now let's prove why that is true. Because I can write these powers as repeated multiplication. So 9 to the 5th would be 9 times 9 times 9 times 9 times 9. Divided by 9 to the 3rd, 9 times 9 times 9. And if I simplify that first, well, I know that these two make 1. And dividing that 9 and 9, that makes 1. And this 9 and 9, well, that makes 1. So I'm left with 9 times 9. Well, 9 times 9 as an exponent is 9 squared. Outstanding. So, ladies and gentlemen, let's look at it algebraically. They're saying algebraically, if I have some letter a to the mth power divided by a to the nth power, I would get a to the m minus n. Now understand that a cannot equal 0 because we know that when we're dividing by 0, that's undefined. So as long as we do not have 0, we are good. So let's do some examples. Dividing powers with the same base, we're simplifying this expression, and it does specifically say write your answer as a power, because if our base is a number and we don't, then we actually have to continue doing the math. But they want us to write it as a power. So here in number 1, 4 to the 5th divided by 4 squared, that would give us 4 to the 5 minus 2, which is equal 4 to the 3rd. It's pretty straightforward. Number 2, p to the 7th divided by p to the 5th would be p to the 7 minus 5, which gives us p squared. And number 3, we have negative 5 to the 12th power, and we have a negative 5 to the 3rd power, so that would give us negative 5 to the 12th minus 3rd powers, which would be negative 5 to the 9th. Pretty straightforward. Let's add a little bit to that and simplify some expressions that are written a little differently. And we're going to write our answer as a power. So the first one, we have in number 4, 5 to the 6 times 5 squared, all divided by 5 to the 4th. Two ways we're going to look at this one, and I'm only going to do it the two ways on this example number 4. The first way is to say, hey, I'm going to do the multiplication in the numerator first. So I'm going to rewrite this as 5 to the 6 plus 2. Well, we know that when we multiply with a common base, we add the exponents. And that's divided by 5 to the 4th. So 5 to the 6 plus 2 becomes 5 to the 8th, divided by 5 to the 4th. Now we're dividing, and so we're going to go 5 to the 8 minus 4, which is equal to 5 to the 4th. So that's one way of looking at it, doing the multiplication first and then dividing. The other way of looking at it is rewriting it to say 5 to the 6th over 5 to the 4th. Oops. And then we're going to multiply that by 5 squared. Well, 5 to the 6th minus 5 to the 4th becomes 5 to the 6th minus 4 times 5 squared. Well, 6 minus 4 is 2, so 5 squared times 5 squared. Now we're going to multiply, which means we're adding 2 plus 2, which again is 5 to the 4th. So we get the same exact answer no matter which way we go. So, ladies and gentlemen, let's move right along to our next example. 5 to the 15th over p to the 15th over p to the 5th times p to the 7th. So I'm going to go p to the 15th divided by p to the 5 plus 7, which is p to the 15th over p to the 12th, which becomes, since we're dividing, p to the 15th minus the 12th, which gives us p to the 3rd. Two more examples of that. We have d to the 5th over d times d to the 9th over d to the 8th, and we can do it a whole bunch of different ways, just like we were just doing a moment ago. We just have more terms. It's okay. So I'm going to take this and I'm going to do the division first. And I'm going to go d to the 5 minus 1, because remember, the exponent is 1 when you don't see it, times d to the 9 minus 8, which gives us d to the 4th, times d, which when we add them, d to the 4 plus 1 gives us d to the 5th. Outstanding. So, ladies and gentlemen, moving right along to the next one. I'm going to switch some colors here because I like being colorful. So I'm going to do it the other way this time, and I'm going to rewrite this as 3 to the 6 plus 8 over 3 to the 2 plus 5. Because I'm actually doing the multiplication of the powers first, so I'm adding the exponents. This would be 3 to the 14th over 3 to the 7th. And then when I do the division, that's 14 minus 7, which gives us 3 to the 7th. Very straightforward. Ladies and gentlemen, we have one last example. It's a real-life application. It says the projected population of Hawaii in 2030 is 5.59 times 2 to the 18th. The land area of Hawaii is about 2 to the 14th square kilometers. Predict the average number per square kilometer in 2030. So, to do that, the first thing I'm going to do is, since I want to find the average, we should know what average. That's like the mean, okay? We're going to find the average by adding it all up and dividing by the numbers. Well, they tell us that we have 5.59 times 2 to the 18th. And we're going to divide that by the number of square kilometers to find out how many people per square kilometer. So this is over 2 to the 14th. Well, we can simplify this by saying 5.59 times 2 to the 18th divided by 2 to the 14th. And what do we do when we're dividing with the same base? That's right, we subtract. So now we have 5.59 times 2 to the 18 minus 14, which is going to give us, I'm going to come down over here, which is going to give us 5.59 times 2 to the 4th. Well, everybody knows what 2 to the 4th is. We have 2 to the 4th gives us 16. So we have 5.59 times 16. And when we do that times 5.59, it would tell us that we have 89.4 square miles, or excuse me, the population per square mile would be 89.9 people per square mile. Pretty straightforward. Pretty straightforward, ladies and gentlemen. All right, so now let's look at our quick write. And of course, I put this in your notes this time because our lesson's not very long. So it's right there in your notes. You can just complete it right in there. You don't have to look at it. Ladies and gentlemen, always a pleasure. Please make sure you come to class with any questions that you have regarding quotient of powers property. It's always a pleasure, ladies and gentlemen. I will see you tomorrow.